Okay, we are on 5.9, the last lesson of chapter 5. We are transforming polynomial functions. So first, our problem of the day, solving by factoring. First, we would take out our greatest common factor, which in this case is 3. And we're left with x squared minus 3x plus 2 equals 0. We can factor that one step further. So our factors of 2 that add to negative 3 are negative 2 and negative 1. And then if we set each of those things equal to 0 and solve them, we would get that x is 2 and x is 1. Okay, so we are learning about transforming polynomial functions. We're going to be able to apply transformations to a function and then find the real zeros of a transformed function. So if you remember, back in the day, we've transformed functions before. So we did, like, if you had y equals x squared, transforming a quadratic, and we did absolute values. Y equals the absolute value of x. So if it was on the inside, it moved it left or right. So if you had it, like, in the parentheses, x minus 2 squared, that would have moved it right 2. If it had a plus 7 on the outside, that moved it up 7. Same thing with absolute value. So if it was on the inside, it moved it left or right. So if you had y equals the absolute value of x plus 3, that plus 3 would move it left 3. If you had a minus 5 on the outside, that would move it down 5. So we're doing that exact same thing. It's just now our parent function or our starting function here is going to be y equals x to the third. So the inside, outside rule things still apply. So if it reflects across the x-axis and it's moving up 2, reflecting it across the x-axis just puts a negative out front, and then moving up 2 would just be a plus 2 on the end, not in parentheses. On our next one, it's moving left 3, so that is going to be in the parentheses, x plus 3 cubed. And then down 5 would be a minus 5 outside our parentheses. Last one like this, a vertical stretch by a factor of 3. We would have a 3 on the outside. It's being multiplied by to stretch it by 3, and then it's moving right 4 units. So on the inside there, it'll be minus 4 and then cubed. So that cubed is just coming from the parent function. It told me to start with y equals x cubed. I just have a plus 2 here on the outside to move it up 2, a plus 3 on the inside that moves it left 3, a minus 5 is moving it down 5. This 3 stretches it by a factor of 3, and then this minus 4 on the inside here moves it right 4. So we're just changing the things around that x cubed to transform and move our function. And then for these, we're going to find the zeros of the function. So to do that, all we have to do is change our y to 0. We want to figure out what x is when y is 0. So 0 equals x minus 3 cubed minus 8. We're going to solve this for x. So to do that, I am going to add the 8 to the other side. So 8 equals x minus 3 cubed. I want to get rid of this cubed, so I'm going to cube root it. Cubed root of 8 is 2, and then this cancels this out. So 2 equals x minus 3. We want x by itself, so we'll add the 3 over, which just leaves us with x equals 5. We're going to do the same thing here on number 5. I'm going to erase these random polka dots that it seemed to have somehow written on here. We are going to change our y to a 0. 0 equals 3 times x plus 4 cubed minus 81. We're going to solve it. So first we're going to add this 81 over to the other side. So 81 equals 3 times x plus 4 cubed. And then we would divide by 3. 81 divided by 3 is 27. So 27 equals x plus 4 cubed. We want to get rid of that cubed root, or that cube, so we will cube root it. Cube root of 27 is 3. These cancel, so 3 equals x plus 4. We'll subtract that 4 over to get x by itself. which makes x negative 1. Number 6, same thing, changing y to 0. We will add this 10 over first. And then we will cube root it to get rid of the cubed. There is no perfect cube root of 10, so I'm just going to leave that as the cube root of 10. This cancels that, so then we have the cube root of 10 equals x plus 1. That didn't need to be in parentheses, but I wrote parentheses, and we're just going to roll with it. And then we want x by itself, so we're going to subtract this 1 over, and it can't really combine. So we have the cube root of 10 minus 1 equals x. This minus 1 is not under the cube root, so we could also write that x equals negative 1 plus the cube root of 10. This might be the better way to write it, but this is the same answer, would be acceptable as well. And then our last one here, we're doing the same thing. So change our y to a 0. 0 equals 1/3 times x minus 1 cubed minus 9/8. And then we're going to add the 9/8 over. And then to get rid of that 1/3, we're going to multiply by 3, or multiply by 3 over 1, which is the same as 3. 9 times 3 is 27. 8 times 1 is 8. So 27 over 8 equals x minus 1 cubed. I'm going to leave that as a fraction because they're both perfect cubes. And so it'll cube root nice. So the cube root of 27 is 3. Cube root of 8 is 2. So 3 over 2 equals, these cancel, x minus 1. We want x all by itself. So we add the 1 over. 3/2 is the same as 1.5. 1.5 plus 1 is 2.5. So x is 2.5. I know that this was a very, very quick overview, but I hope it at least gives you enough that you can get started on your homework and I can clear things up when I return.